Okay, we're going to go ahead and start off with number 42 today. So we're going to start getting into some vector problems. So this is a vector problem that says a golfer hits a ball from the ground at a 20-degree angle to the horizontal, that's the ground, with an initial velocity of 132 feet per second. The first question is just asking us to model these using parametric equations. So the equations that I'm going to be using are on the formula sheet for your review sheet. Okay, so we have two equations in terms of time, x of t modeling the distance horizontally in time, or as a in terms of time. Okay, so just to review here, we have v naught is the initial velocity, theta is the angular velocity, and h naught is the initial height. So here, you literally just have to plug in the things you know for part A to be answered. So you have the initial velocity was 132 feet per second, and then our angle is 20 degrees. Okay, and then y of t. And if you notice here, it says that it's from the ground, so my h naught is actually 0. So I'm going to leave that alone. So there's part A. Part B says, give the location of ball after 2 seconds. Correct it 3 places after the decimal point. So here, I just have to plug in, I know what t is, it's 2. So I'm going to plug in 2 for x, the equation for x and the equation for y. One note here, make sure that you are in degree mode on your calculator because they did give us an angle in terms of degrees. So when you do this in your calculator, your x, your horizontal distance is 248.08 feet. And your vertical distance is 26.29 feet. So there's part B. Okay, and I'm actually going to continue this on the next page because the third part is kind of the longest part. So this is number 42, part C. How far is the ball from the golfer when it hits the ground? So the trick or the strategy to answer this question, you're going to see this on the next question too, is to first find the t value where the ball hits the ground, because both of the x equation and the y equation are both in terms of t. So I can't do anything with regard to the distance and the height unless I know the t value. So how far is the ball when the golfer hits the ground? So we're interested in the y equation being equal to 0. So really what we're finding is y of what is 0. So the way I'm going to do this is I'm going to go into my calculator. Again, I'm in degree mode, and I'm going to use the y1, y2 menu, where y1 I'm going to set equal to 0, y2 I'm going to set equal to this equation here, actually here, okay, leaving t blank. So if I go here, I have y2 we'll say is negative 16 t squared plus 82, sorry, I was looking at the next problem, plus 132 sine of 20 degrees, okay, times t. And so now what I'm going to do is I'm going to graph these in the calculator. Notice this is a calculator problem. Okay. Okay, and when I graph these, I'm going to do it in a few steps just to review how you can use the zoom button. So the standard zoom, the picture roughly looks like this. It's not very good at all, but it actually will get the job done because I'm interested only in this point here where it crosses the 0 line. So I could actually use the 0 tool. If you go to second, you write down the steps. So go to second trace, okay, which takes you to the calc mode, and then choose either one of two things. So since I graphed two things, I'm going to use the intersect tool. So this is the one that I'm going to use. But if you also just want to not graph a second graph here, y equals 0 will be on there whether you write y1 equals 0 or not. You can also just put this in y1, graph it, and see where it hits the x-axis, because that's really what this is. This is the x-axis. So if you do it that way and you're just having your y1 spot filled, you're actually just going to use 0, the 0 tool, because that's what you're finding. Because I have 2 points here, or 2 graphs that I chose to write, I'm going to use the intersect tool. Okay, and so when I use the intersect tool, I find that this point here is, it will give me an x value, but it's actually a t value. So keep that in mind, because everything is in terms of t. So the t value where y is 0 is 2.822 seconds. Okay, and you want to try and do the least amount of rounding here. You probably will have a little bit of rounding error, but that's okay. So now that I have this, okay, I can actually answer the question and say, you know, how far is the ball from the ground when it hits the ground? So how far, not how high, how far, that is an x value. So now I'm going to do, say, C continued, x of the t value that I just found, which was 2.822. Okay, and if you plug that in, you get out 350.039 feet. Okay, so that is your answer for how far the ball is from the golfer when it hits the ground. Okay, so now we're going to continue with number 43. So these are some of the more, not, well, you could say tedious, or the problems that take the longest on the exam. So number 43 is very similar, but it's talking about a punter kicking a football. Same thing for part A. They ask for the equations, the parametric equations. So here we have an initial velocity of 82 feet per second with an angle of 63 degrees. So there's our x of t equation. Our y of t equation is going to be negative 16t squared plus 82 sine of 63. Again, we're in degree mode, t, plus 2, because it says that the initial height is 2 feet, so it's not 0 anymore. This n number will now actually be a number other than 0. So there's part A. Part B is, what is the position of the ball at t equals 1.5, so you plug in 1.5. to both the x and y equations. Okay, so your x value will turn out to be 55.84 feet. Okay, and then your y will be 75.593 feet. Okay, so there's parts A and B. I can continue part C over here. So part C says, a player who is 6 feet tall is standing 50 yards or 150 feet, since we're in terms of feet, from the punter directly in the path of the kick. Will the ball go over his head? So again, I can't say anything until I know how much time it takes the ball to actually go 150 feet. So that's my first step here. So in other words, I need to know a few things. So I'm going to say, I know that I'm interested in the ball going 150 feet horizontally, but I don't know the time that it takes to do that. So I'm going to use a very similar approach to the last question. Use my y1, y2 in my calculator. This time I am going to use both y1 and y2. You don't have the option of not using, last time we could use just the 0 tool, but this time you're going to have to definitely use the intersection tool. So I'm relating the distance this is a x value, right? So I'm using the x equation down here. Make that a little bit nicer. 63 degrees T. Okay. So I'm going to go ahead and graph this. Okay, and I'm going to try and walk you through the best I can with the zooming analysis with this. So if you graph this in the standard zoom, you can't see anything. You can see the, I guess the first kind of snippet of the graph. It just goes straight up, and then that's all you see, and just goes off the graph. The reason for that is because the y value is so high. The y value is at 150. So one thing I'm going to do here is I'm going to go from standard zoom to something called zoom fit, which is all the way, that's option 0, which is all the way at the bottom of the zoom menu. And that's just kind of a nice way to get everything to fit on the graph. So when I do this, this is what I get. I have the line here of y1 equals 150. That's that flat line here. And then I can see that the other line is linear, which actually should not be surprising. This is a linear equation. Okay, the t has a value of, or a degree of 1. And so I'm interested in this guy right here. What is this t value where they intersect? And if you use your intersection tool, okay, you'll see that t is 4.029 seconds. Okay, so now I know exactly how long it takes for the football to get to the guy that's 6 feet tall, saying 150 feet away. And now I can start to do some interesting things here and answer the question. So let's continue part C over here. So now I need to know at 4.209 seconds, okay, how high is the ball? So I'm going to simply plug in that number, 4.029, into the y equation. And when you do this, you'll get out 36.64 feet, which is definitely greater than 6 feet. So the answer is yes. The ball will go over, definitely go over, will go over the man's head. Okay. Okay, and then we do have a part D to this question. It's very similar to the last question. So as far as, I believe it would resemble part C of number 42. Suppose that the ball hits the ground. When will the ball hit the ground, and how far from the punter will the ball hit the ground? So they're asking for, first, when will the ball hit the ground, which is actually kind of a leading question. You need to know the t value in order to answer the second one, which will say how far from the punter will the ball hit the ground. So I need to know x of what t value. So I'm going to find this guy to get the distance from punter when ball hits the ground. So in order to answer this question, to find the distance from the punter when the ball hits the ground, I need to find this guy first, this t value, right? So I'm going to use a very similar strategy as last time. Okay, so I know that I'm interested in y of some t value equaling 0. So what I can do is I can go to my y1, y2 menu, and this time I'll do it the other way. I'll just use y1 since 0 is going to be on the graph no matter what. That's the x-axis. So I'm going to say y1 is the height equation, which was negative 16 t squared plus 82 sine of 63. Again, we're doing everything in degree mode. Times t plus 2. Okay, and I will go ahead and graph that. So even if you're in the standard zoom, you'll be able to see this. Again, it kind of shoots off the graph, but then eventually it comes back down. You don't actually see this top part. Again, this is the standard zoom. So the t value here, which is what I'm interested in, I'll use the 0 tool this time. So if I use the 0 tool here, I can find that the t value is 4.5 4.594 seconds. Okay. So now I can answer actually this question here. The first part of the question that says, when will the ball hit the ground? Well, this is the answer to that one. Okay, so we'll circle that as an answer. So the ball will hit the ground 4.594 seconds. And now, how far will it be from the punter when it hits the ground? That is an x equation. So I'm going to use x of that same number, 4.594. And when you get that plugged in, you get 171.008 feet. So that's how far it is from the punter when it hits the ground. Okay, so there you have numbers 42 and 43. I know the whole video was just those two questions, but there were a lot of questions involved, a lot of graphing, so just make sure that you make sense of all of it. And I will see you next time. Thanks for watching.